Thank you for coming here today. Sorry, we are not going to talk about any date. I'm not sure this talk is going to be very romantic. I will try to make it as interesting as possible for you today. We are going to talk about how to handle date objects in a Kotlin world. This talk is from beginner to, I hope, more advanced engineers. Disclaimer, this talk is not about reviewing the whole APIs, but to understand what are the problems we solved as engineers and how to find things that suits our need on a daily basis. I did some research while I was preparing this talk, and I found this topic quite interesting. During this talk, sometimes you will hear fun fact based on my research, because it was based on funny things that I discovered. So don't worry if you hear me saying a lot of fun facts. The first question we're going to ask ourselves today is, what day is it today? This question may be strange at first, but we are going to explore that it's not so easy to answer to this question because of some constraint that we are all facing in this world. The first problem is, well, we are using different calendars. I found this graphic quite nice because as of January 1st of 2023, as you can see, we have different calendars like the Hebrew, Chinese, Gregorian, Islamic. We even French have this French revolutionary calendar that we are not using anymore. But back in that time, they were like, let's do a revolution and let's create a new calendar. So basically, the most common one is the Gregorian calendar. It's a solar calendar, meaning it's based on the length of time it takes the Earth to orbit through the sun, around the sun. It was introduced a long time ago in the 16th century. It was a reform of the Julian calendar, so it's a very old one. It's the most widely used calendar in the world today. And it's also the standard calendar for all the civil purposes. It has many particularities. The number of days varies according to the month. The number of days in a year varies according to the year, if it's a leap year or not. And fun fact number one, this Gregorian calendar is not accurate. Within a day every 3,000 years, which means that over time we will slowly drift out of sync with the solar system, the solar year, sorry. Well, we have time for this, but still good to know. The second problem, we are living in a world with different time zones. There are 24 regions around the world with a difference of 1 hour. As you can see, time zone tends to follow the boundaries between countries and their subdivision instead of strictly following the longitude. That's why you can see between Portugal and England, with the rest of Spain, France, there is a different time zone here. The offsets are usually a whole number of hours, but some few zones are with an offset of 30 or 45 minutes. We have this in India, in South Australia, and in Nepal. So it's not only 1 hour. And we have, of course, 24 time zones. We have the time zone database. It's also known as the TZ data. It's a collaborative compilation of information about the world's time zone. Fun fact number two, we also know the TZ data as the Olson database. It's a reference to the founding contributor, which was Arthur Olson. So that's why you can see sometimes Olson database or TZ data. There's many fun facts here. So this is an abstract of the changelog for the latest update of time zone that occurred in March. As you can see, you can find it online. It's the changelog. You can find all the change of time zone that occurs at this moment in the world. For example, on March, there was a huge mistake because Lebanon, they said, okay, we are going to change the daylight saving time to tomorrow. And They updated the time zone database, and then they said, no, not today, maybe the day after. So they had to update again. So during one day, the data zone in Lebanon was completely out of sync. That's why they can see chaos by reverting data in the TZ data, thanks to Randy Annie for the heads up. We have also some brief, like Egypt is now using daylight saving time again, all right, from April through October. So they were like, okay, let's not use this one anymore, but now we are going to use this. This year, Morocco Springs Forward will be from April 23rd to not April 30 as it was expected. So we have to update it. Another fun fact was, okay, let's rename the Pacific Enderbury to Pacific Canton. Why? As you can see below, nobody was living. It's in the close to Australia. Nobody was living in this area, so everybody on the island near to this one were referring to Pacific Canton, but nobody was living there. So after 30 years, they decided to, okay, let's rename this. So it makes more sense for people. So it took 30 years to rename it. But still, if you hardcode this value on your Android app, then you might have some issue. So that's the second problem, the time zones. The problem number 3 is that the rotation of the Earth is not regular because of the tidal effects due to the moon and the sun, unfortunately earthquakes, and as well as other unpredictable or irregular internal phenomena. So what we decided? We decided to create let me put it here, the universal time, known as UT. It's based on the Earth rotation, so it varies. Then we created the International Atomic Time, so it's the average of time that is kept by over 400 labs in over 80 national laboratories. So it's kind of atomic clocks, and they are all in sync. So we are sure that this is the atomic time, and it's never changing. So we have the universal time based on something that varies. We have the International Atomic Time, which is perfectly, I hope, always in sync. So what we did, we created UTC as the Coordinated Universal Time. It's a time scale between the TAI, which is stable but disconnecting for the Earth, and the UT, which is directly related to the Earth. And this is now the primary time standard by which the world regulates clock and time. Another fun fact, on December 31st of December 2016, we had 1 second. And it means that at the time we had a time lag that was increased to 37 seconds between the International Atomic Time. So by adding sometimes some seconds, we can ensure that with the UTC we have this compromise between the universal time that varies and the International Atomic Time. There is not, sorry about the fun facts, but I found that very funny all the time when you look at this. But in French, we are saying TUC, which means Temps Universel Coordonné. In English, it's CUT for Coordinated Universal Time. So people agree, like, let's call it UTC, which means nothing in French or English, but let's agree on this. So that was very nice. Of course, the difference between GMT and UTC. The GMT is the Greenwich Mean Time. It's based on the solar time, and the UTC, as I said, it's a mix between the atomic and the solar time. That's the difference. Okay, that was the problem we are facing on the daily basis. We are engineers, we are building tools, and what we figured is that we could have two things: the machine time management and the human time management. Let's have a look at the tools that we build, and first let's start with the machine time management. you might be aware of the Unix epoch, or the epoch. It's the Unix time, which is a date and time representation that is used widely in computing. We know the leap seconds 6 months in advance. Basically, it measures the time of seconds that have elapsed since January 1st of 1970, the beginning of the Unix epoch. And we made some adjustment with the leap seconds through the time. I'm mentioning the year 2038 problem because back in that time we were using a signing 32 bits integer, and the data type was only capable to handle the integer between -2 power 31 to 2 power 31 minus 1. So meaning that we had a problem of encoding, so that's why we went from 32 bytes integer to 64 byte integer. That's why if you're doing C, then you will find some time 2, I think, or there is a new type for on this on C. Yet it was not a problem anymore since we have 64 bytes integer, because with this we are okay for the next 300 billion years. So that should be okay. I was referring to the Unix epoch, also known as the epoch time, but actually you can create your own epoch. It's just like you say, okay, let's take January 1st of year 2000, then it's your epoch. So when we're saying about the Unix epoch, it's the January 1st of 1970, and it's called the epoch, like the first one. We also created the ISO 8601, and there is some general principle, and this is a solution that we found that actually provides some machine time management, as you can see here. You might be familiar with this notation, and also some human time management, because we can understand what time is it here based on the first part, the time, and the time zone. So this standard is covering the worldwide exchange and communication of date and time related data. The date and time value, they are ordered. Sorry for the American who put the months after the days, but order from the largest to the smallest unit of time. So it's year, month, day, hour, minute, second, and nanoseconds, for example. When you look at this, actually, it's not so complex. There is some strict rules regarding this. So there is the year, the month. You can find all the notation. It's very easy to find it even on Wikipedia. And then we have this plus with the time zone. Fun fact, you might have asked yourself, why Z? What does it mean? Z is something which means the UTC, or means nothing. And why Z? Because it means Zulu. And it was the navigators where they were saying like Alpha Bravo, so they were saying Zulu time. And we kept the Z for Zulu. And that's why the Z means UTC time. So when you put Z, it's just like to avoid put plus 00, semicolon 00. Okay, so that's the tool we had, the epoch and the ISO 8601. Now we're integrated engineers, we're working on the JVM. So sorry, it's a little bit of history of time in a Java world. I tried to do some research and I built this line. That's what happened. So in 96, we created Java 1 with Java util.date, then the calendar, and we're going to go through these steps that mark the history of managing date time in the Java world. So the first one, the Java util. So the Java util. So basically, if you find some import on your project, migrate, don't use it. This is not good at all. It has some serious design flaws. From the day it was introduced, many of these methods were deprecated right after Java 1.1. So they tried to fix some of the problem in Java util calendar, which I was mentioning the year later. And they created even a java.util Gregorian calendar. So why I'm saying this? The Java date is poorly understood by us developer. Unfortunately, it has been badly abused by many library authors. adding further to all the confusion that was. For example, a date instance is not a date, it represents an instant of time. It's not a date. So importantly, that means that it does not have time zone, you don't have format, it's not linked to any calendar system that I was mentioned before. Some other problems are it rates the years as 2 digits since 90. There's many workaround in the Java world because what I put is, as Kotlin example, there is mutable value. So you can put a date and change the year, the month. I tried that on day. I don't know why it doesn't work on day. So day is unmutable, but years and months are mutable. And as you can see here, I put year to 2023, but what it does print is year 3093. Why? Because it starts at 1900. So it's adding values. It's not the values that you set. So that's why it was a little bit complex. So bottom line, don't use javautil.date. So then we had this Java time and 310 ABP. So that's kind of a funny story what happened here with the time. What's time? It's what they brand a powerful and versatile date and time library. It was an alternative since java.util.date was not good. It was created in 2002 and it was born out of the frustration with the existing Java date and Java calendar APIs. It aimed to provide a simpler and a more intuitive API for handling dates and time. This was with this design that we used this design to define the GSR 310, meaning we went from this to 310. So the GSR 310 came from all the good things that went from Joda. And what is 310? So basically, we created the GSR 310 to put it in Java 1.8. Unfortunately, not everybody was using Java 1.8 at that time. So what we did, we created 310 backport that works on Java 1.7. But this 310 backport is not handling time zones, and it has to be plugged within the jar. So the time zone rules have to be inside the jar, which was not the case back in that time. So that's why we created the 310 ABP, 310 Android backport. If you look at the project, you will see that it has some similar to the problem that we were using when using Joda time on Android. It's a big jar where the time zone are loaded inside the library. If you look at 310 ABP, you will find a script called update.sh, and you will find that what is build doing, it just get from the TZ data the latest build, the latest time zone, it put it in the correct folder, and it's building the library out of this. So we know that it's basically every time we update the TZ data, we get the latest version of the time zone within the 310 ABP. So it's a backport, and what I was saying is that, and we are going to move toward this, please use java.time now. So that's perfect. It's the Java time. So let's explore what we should be using now. It's Java time. I was mentioning this machine time management, the human time management. This representation can be done into these two models. The machine time, basically, it's a long integer whose value is in amount of time in a defined unit. It's the elapsed since a point in the time, like the epoch time in this case. And the human time is the representation that we have seen through the ISO 8601. For this part, let's have a little bit a little look of how it works under the hood and through the API. So let's go to the machine time management. The instant, you may be familiar with this. So basically an instant encapsulates a point in time with the nanosecond precision. It's just a point in the timeline. This instant class is the closest that we have from closest class to the java.util class. How does it work under the hood? You can do just instant.epoch and it will print the epoch time, or the now and it will print the time that I had yesterday when I generated it. And it's in the format of ISO 8601, so it's readable when you print it. We also have the duration. It's the time between two instants stored with the nanosecond precision. Notice that duration can be negative, and there is something that I didn't mention in the ISO 8601, that we have also a textual format for duration, starting with the P time and then the value, and you will see in a moment, and there is the number of hours followed by the H, the number of minutes followed by the M, and followed by the S. I'm out of time? Sorry, I have to rush a little bit. How many? 1 minute past? Okay. So, sorry if it took a little bit long. We are all engineers. I know that you all can read the manual, to be polite. So let's skip to this. The time zone here. So, of course, we can set up the time zone. But what I would like to finish is with the Kotlin XD time. That's the question you might ask yourself. It's in alpha stage still. It has been a long time in alpha stage, but the development continues. It has the multi-platform supports, and what is great is it's serializable by default. So when you manipulate this value, it's serializable, and it has a simpler API. You will find also some syntactic sugar, like you can give it an ISO 8601, and you can use the toInstant, like extension function, and right out of the blue, you get all the value that you want in the Java time under the hood. And for my conclusion, how about today? What to use? So I spoiled a little bit, Java time, but we have this project mainline. What we are doing is, it's on top of Treble project. It simplifies how developer deliver update to the Android ecosystem. The time zone rules can be updated through a dedicated module using the Apex file from the OEM through this project mainline. Basically, we should not have to bundle the time zone inside our app. We should rely on the device. But the problem, if the device is not up to date, we are screwed anyways. So we have to be sure that the time is correctly set on the device, and we should rely on this. So my personal opinion on what to use, I mean, it depends. Are we building an app from scratch? Do we have an existing code base? Back in the day, the answer was, use these datetime libraries that bundle the data and update your app, and you will be always good. Today, I'm not sure. We should ask ourselves, what are our requirements? Are we building a calendar app? Are we having a strong usage of time zone within our app? Is it okay to not handle this? What is our minimum SDK? What are the user? If they have the latest phones, then they can have Play services installed, and they will benefit from the project mainline. I rushed. So that's it. Thank you. If you have any question, please reach me.